The next few examples deal with applying the concept of average rate of change. In example 7, at the start of a trip, the odometer on a car read 67,828 miles. At the end of the trip, 13 hours later, the odometer read 68,686 miles. We want to find the average speed of the car during that trip. To do this, we want to set up two coordinate pairs. There's a missing piece of information, or a piece of information we have to infer from the problem. Our two variables are time and mileage. What's not explicitly stated is that at the start of the trip, we're at a time of t equals 0 hours. So our coordinate pairs will be 0, 67,828, and after 13 hours, a mileage of 68,686. What we want to do is find the average rate of change through those 2 points. To do that, we can find a line through those 2 points. Which gives us an equation in slope-intercept form, but all we're after is just the slope of that equation, which is the rate of change between those 2 points, which is 66. So the average speed of the car in this case was 66 miles per hour. In example 8, we want to find the average rate of change of total profit as production changes from 12,343 to 12,958 units for this given profit function. We can do this in Symbolab, but in this case we're going to need to pay very close attention to some of what we enter here. We're going to ask Symbolab to find the average rate of change, and then we need to make sure we enter the function name and function notation. So we need to include p of x is equal to negative 0.172 x squared plus 5,038.396x, and I'm typing in that exponent, so let's go back. So we've entered that entire function, including that p of x equals notation. Then we're going to put a comma, and inside a set of parentheses, we're going to input the lower and upper bound for these production level changes. So 12,343, comma 12,958. And what it'll calculate for us is that average rate of change, which in this case is 686 point, we'll round that to 62 since this is dollars. So $686.62 per unit is the average rate of change of our profit function as production increases from that first value to the second value. And note that in this case, we did have an increase in our production levels. That'll be a little bit different than what we see in example 9. Here we have a company that sold a particular product for $68.31. They sold an average of 1,340 units per month. When they increased the price by $4.10, average monthly sales dropped by 54 units. We want to construct a price demand equation. To do that, we need two coordinate pairs. We're given that information, though not explicitly, because we're given the original price point and how much the price increased by. Adding those together gives us the new price point of $72.41. And then we can look at our production level, which dropped by 54 units, to get our new production, or our new sales level, not production level, of 1,286 units. So we increase the price demand or monthly sales dropped. Now we want to construct that price demand equation. We'll do that using demand as our independent variable. So our two coordinate pairs here will be 1,340, comma 68.31. Those were the two original values given to us. And then the new values will be 1286 and that price point of 72.41. Just like we did in example 7, we can use Symbolab to construct the line through those 2 points. And we would end up with the price demand function P of x is equal to negative 0.0759x plus 170.0507. Again, Symbolab will give us that in terms of x and y. We just need to know to change y to be P of x to represent that price demand function. Then in part B, we want to construct the revenue function for this scenario, where r of x will be equal to x times our price demand function. Distributing x through will give us negative 0.0759x squared plus 170.0507x. And then in part C, we want to find the average rate of change of total revenue as demand changes from 1,340 units to 1,286 units. So unlike in example 8, now what we're doing is decreasing our production level. So we'll approach this like we did in example 8. We'll ask for the average rate of change. We'll input that function notation and the equal sign and then the expression itself. Then a comma, and then in a set of parentheses, we'll put that range of production levels, but we need to make sure these go from a lower bound to an upper bound. Even though the problem gives it to us in the opposite direction, mathematically we have to include the lower value and then comma the larger value. And what we get is, since this is dealing with money again, negative $29.26. Per unit. But that was the value that we input going from a production level of 1,286 units to 1,340 units. In the context of the problem, we're actually moving in the opposite direction. We're actually decreasing our production level. So we have to sort of know intuitively to flip this and make that a positive $29.26 per unit. So our average rate of change in this case would be $29.26, a positive $29.26 per unit, which we have to infer in the sense that we're